Here, we were talking about the Android device routing lab, Task 1. We see that the Android device routing it's mainly because of using the OTA package. The OTA package is called the over-the-air package. It's the Android used to update the system. Uh, so the OTA package will run on the Recover OS at the very start of the system. So it is a very good breakthrough to the system, because once we get into the system, we can no longer get the control. We only can do it before the system started. So the OTA package is a good access point for this attack. Now we just follow the OTA package structure to build a file structure exactly like the OTA packages. You can see we have net info, we build com, Google, Android, and the update binary file is the most important file that it's executed by the Recover OS and apply the OTA upgrades. We can see the path is correct, and now we need to put a dummy shell script into the dummy.shell. Once this dummy.shell is run, in here we said we will print hello into the system .dummy file. After this is done, we save it. Now we need to create an update binary file which will run this dummy.shell when the OTA package is run. Not when the OTA package is run. We probably want to put the code running before the Android system initialed. So we need to find where the system initial is located. We will copy this dummy.shell file, to the Xpin, and then we make it executable, and then we can execute it in the initial file before the Android OS actually start. We want the dummy.shell running before the return zero of the initial shell file of the Android OS. After that, now we can see that dummy.shell and update binary is being created. Now we need to build this OTA package, zip it, and send this to the real Android virtual machine. From the zip file, we can see the file structure of the OTA package. Um, Everything is correct. Now, before we send this package to the Android OS or Recover OS, we need to know the Recover OS IP address. So let's restart it and go to the Ubuntu's Recover OS system to find out what is the IP address it is. We see that the IP address is 0.10.0.27. Now we're using SCP to transfer the OTA zip file into the IP address we just found out. We just found it. Here we can see the OTA zip file is already being downloaded. And now we need to unzip the file. After that, we can run the update.binary. Then all the code inside the update binary will be run. This in the real Android, it actually should be run automatically, but here we have to do it manually. So let's run the update binary. Some issues here. I don't know what happened, but basically when I redo it when I checked the permission and it tried to run, I have typing the wrong words on the updated binary, between the updated binary, the line between. So later, when I successfully for running the update binary, the dummy.s.shell file will be injected into the initial.sh, and because it is running, so when we get into the Android OS, we should see the dummy file. It is inside of the system XB. Okay, after reboot file, let's go to the Android OS. Let's go to its system. And we can see dummy file is over there. That means the injection is successful.